Yeah, I think we've got quite a few people on the line. Let's get started.
Sure. Alrighty. Thank you, everybody, for attending. My name is Dave Friesen. I sit on the board of Nova Hydromet, and I'm just going to do the introductions today. So first, we've got Lena Klebanov. Uh, Lena holds the position of the managing director at Samgard, where she oversees a diverse team dedicated to predictive maintenance solutions in the process industry. She's got 15 years of experience and spearheads initiatives aimed at fostering innovation and improving operational efficiency. Lena earned a Bachelor of Science and Bachelor of Arts degrees from Technion, which is the Israeli Institute of Technology, with a focus on information systems engineering, economics, and management. Our other speaker will be Maya Rubin. And Maya serves as the Vice President of Customer Success at Samgard, bringing over a decade of experience in various management and engineering roles within the chemical industry. With a bachelor's degree in chemical engineering and an MBA, just hands-on experience. And Maya is entrusted with overseeing the digital transformation, the support team, and ensuring continuous product improvement and adaptation to real customer needs through feedback that her and her team collect. And finally, the monitor for the meeting will be Brant Mock. Brant is the president of Nova Hydromet. He has his PhD in civil engineering from the University of Texas, where he does research on industrial commissioning and startup. That was his PhD thesis. Together, he and his dad, Rob Mock, helped CGIS found the Nova Hydromet joint venture group. So with that, I will turn it over to Brant.
Thanks, Dave. Appreciate that. I see we've still got some people coming into the webinar. We've got over 50 now. Thanks for making the time, everybody. I'll go over a couple of little housekeeping things before we get started in earnest here. As we go along, if you have questions, please enter them into the Q&A that's on the Zoom bar at the bottom or the top of your screen. And type them in there. I know that Sam will be looking at the questions as we go along. I'm happy to answer questions at any of the end of any of my sections. We'll kind of let Sam be the monitor of those questions so we don't miss any, but certainly at the end we'll also be answering a lot more of the questions, and anything that comes up, technical questions about how the predictive maintenance works by AI, or how practical questions about how the software works, things like that, or even more generic questions about sort of what Nova Hydromet does more generally. Those are all good questions. No problems there. Go ahead and feel free to type those in. I see we may even already have another one. There was a question before about a recording. So this webinar is being recorded, and a link to the recording will be sent out to everyone who registered for the webinar. So if there are members of your team that wanted to see it, or I know that we have some people that were registered but are not in a time zone really convenient for this time, so they'll be able to watch it tape delay. So I think that Sam will be sending that out after the webinar is over. I think we're probably all good there. Sam, stop me if I'm forgetting anything, but otherwise I'll kind of get into this a little bit.
No, you're good to go.
So we really appreciate Lena and Maya joining us today. They're our good friends from Samgard, and we'll talk a little bit more about the software, what it does and what it is. They're based in Israel, and they obviously are the experts on what the software is because they work for the owner company of the software. So I'm Brant, and I'm the president of Nova Hydromet. Just so that you all know what the connection is, CGIS is the parent company of Nova. I'll talk a little bit more about what Nova is and what we do here in just a second, but just to make that link clear and to help everybody understand. So Nova is a Canadian company and was really founded to help focus on the pressure hydrometallurgy industry. Facilities that have autoclaves, facilities that are doing refining of metals via slurries, facilities that use really, really high pressure and high temperature processes. These are the kinds of things that we focus on. However, our conversation today will be a little bit more broad. So SamGuard is applicable to all process industries, the software that we'll be talking about. And of course, the ideas that we're talking about are also widely applicable even outside of process industries as well. So we're, talking about how to use artificial intelligence and how to leverage lots and lots of data that's already being collected. So I don't want to get too far ahead of myself here. I'll give a brief description in case any of you are curious about Nova Hydromet. Feel free to reach out to us about other things that we do or other products that we offer. Nova design and manufactures some of our own valves under our own name, including some of the ones you see here on the left of this screen. So we have the tall one there is our angle control valve, and that's made specifically for severe service applications. We do severe service isolation ball valves, as well as some other products that you may be familiar with already through CGIS, DSS shear gate valves and high-grade check valves. We also make some other ancillary equipment as well. That's not the focus of this meeting, but just to help everybody kind of understand what the connection is with CGIS. And so we know and we collaborate with our colleagues at CGIS quite a lot on a number of different things. And so if you have questions about, this software or anything else about Nova, you can reach out to Sam, that's just fine, or even Dave, and they'll get you connected up with us. As part of our strategy at Nova, we don't just sell equipment or valves. Really, a lot of our philosophy is based on mathematical modeling of systems. So, the physics of the systems, controls, doing sizing of valves, as well as system lines and tanks and things like that. But it's all based in mathematics and physics and first principles. And this is something that Rob, my dad, is the expert on when we talk about pressure hydrometallurgy. And you can see some of the modeling images there. That's all that I'll say about that for now. But some of the problems that we encounter that we're helping clients with have to do with issues that are recurring, things that they've seen for a long time in their processes at different types of process facilities, whether, that's something in pressure hydrometallurgy or possibly even, something in oil and gas or something else. Where they're having an issue, it may be related to sizing, control, and sort of like a multi-phase media, something that has entrained gases and that also has solids in it. There's a number of different processes that use that kind of thing. So complicated problems, but we use a bit more of a mathematical approach to solving those issues. Now, as part of that effort, we also use data and software, right? So there's a data analytics portion of what we do, using process information to try to understand what types of problems are occurring or to diagnose different issues. Often that has to do with valves, right? Because valves are the biggest component of what we do. However, we've been able to make this partnership with SamGuard, which we feel very fortunate about, because they already have a product which leverages all of the data that's being collected, whether your facility is using a data historian or a data historian and DCS, or even some other format possibly. Lots and lots of data at many of these facilities, whether you're talking about an oil and gas facility or whether you're talking about a refinery of some kind, or a metals refinery of some kind, or even, as far, something like a cement plant, or there's all kinds of different facilities that are collecting vast amounts of data. And so what SamGuard does is help us leverage the data that's already being collected, not necessarily making some big investment into collecting a ton of different data or more data. It's more about you're already collecting lots of data, and how are you going to use that to help yourself, right? So I'm going to explain a little bit more about that. And Maya or Lena, go ahead and interrupt me here if I'm skipping over something, some of the basic knowledge here that's important for us to say to begin with. And Sam, if we have a question come in here at the end of the next slide, is not a bad place for us to address one or two of those. If you all are seeing the next slide here, so this SamGuard software is really what it is artificial intelligence predictive maintenance, right? So it's using the data that you're already collecting from your site or your equipment of whatever type it is, or your system. It's taking that data and it's doing advanced analysis on it, and then it's using that to say, okay, I'm going to predict where there's going to be failures occurring in your equipment, right? And it's this interesting idea, right? We're going to talk about how failures occur in equipment, and how that data relates to processes and some of those things. But we tried to put together a slide here which kind of gives a really, really high level 10,000 foot view. So essentially, the software uses machine learning to analyze the process data, and out of that it generates alerts or alarms or flags, however we call them. It raises its hand and it says, hey, I think that there's an issue, or there's going to be an issue in the future with X, Y, or Z piece of equipment, right? So it flags those for you. It doesn't tell you what the failure mode is necessarily, but it tells you it looks like there's going to be an issue based on variances in the data, and it looks like there's going to be an issue with this piece of equipment. It really zeroes in for you. And so, as far as fixing problems and diagnosing them, that's giving you a huge part of the battle is already won for you, right? You're not walking around your facility trying to guess where the next failure is going to occur, because equipment does wear out and failures do occur. It gives you a really, really specific indication that, hey, there's something wrong here and something's going to happen. We're going to talk about sort of how it does that. But once it does make those recommendations, right, once it raises its hand, that's when we hand it over, right, to the human component, to the team that has experience, which is a combination of your team on the ground, right, your maintenance and your process people, as well as support from SamGuard itself, and then Nova also can lend support in that process to say, okay, the software is telling me that there might be an issue here, right? And what is it, and how do we fix it, right? So what this all ends up with is it gives you an edge over emergencies that often occur. I think that unfortunately, there is an emergency culture, right? Firefighting or putting out issues that occur only, when they sort of become catastrophic, not for a lack of effort or a lack of intent, certainly, but more because that's sort of the way that things occur. And so we're going to look at a little bit of a culture or a paradigm shift as well, as far as, how do we change from firefighting, right, as it were, to preventive maintenance, right, to making fixes beforehand. I know that there are other philosophies about, how this is done. I know that there are DCS programs which you might at first say, well, it sounds like my DCS is maybe already giving me an indication of that. SamGuard is definitely not DCS. It's quite different, and it's quite unique in a number of ways, and we're going to talk about those. So Lena, I'll pass this over to you for the next couple of slides here to talk about a little bit more generically about the software, and then I'll talk about how failures occur, and then we'll hand it back over to Lena.
Thank you, Brent. I'm very happy to participate in this webinar, and thank you for coming. I will start by saying that what are exactly the SamGuard benefits. The first and the main target of our software is increase the production availability by preventing in time any upcoming, both known as well as unknown failure. We could provide the opportunity to the plant team to make a preparation. Additionally, this SamGuard could reduce the potential for human errors, which could lead to the unscheduled maintenance time. The main nature of the SamGuard is avoid the emergency. We will notify you months, week before the upcoming failure is coming. So we will have a time and your team would be much more focused on the day-to-day work instead of get fired by emergencies. Our software will provide you an opportunity also to minimize emission and optimize energy use. A little bit more about the SAMGuard and where it's already installed. Previously, our focus was mainly on petrochemical and chemical industries. And within the time and from the last several years, we are expanding this focus to the cement, hydrometallurgy, and so on. Our company was nominated and winning the Technology Pioneers in 2018 by World Economic Forum. As part of our solution, we have 5 patented algorithms in Europe, America, and China. Each of them are continuously working as part of our solution. The one is focusing on identifying the abnormal behavior. The second is responsible for finding the root cause within the responsible sensor inside and to present it to the user in a more related moment. Another point that need to be emphasized that our models would be continuously recalculated and would be built based on your data and based on your diagrams. Additionally, we put a very great focus on a data security issue. Therefore, we passed annually exam of ISO as part of our company as well as solution, in which we have been checking by the system for any kind of security vulnerabilities.
Yeah, thanks, Lena. I'm going to backtrack here just one slide and talk about this before I get on to how failures occur. You know, I think Lena said it, you said it well here, talking about sort of these 5 different categories of benefits. I think when we have discussions with different clients about issues that they're having, making the economic case becomes quite important. And for most plants that we're dealing with, and it almost doesn't matter what your process media is, you know, what you're doing, you're producing something, right? Or possibly you're managing some system. You know, uptime is generally your greatest economic driver, right? And it's so powerful that often when you talk about 1 day of uptime for many processes, right? Whether it's a refinery or it's a metals facility or it's an oil and gas facility, if you talk about 1 day of downtime for the whole facility generally, you know, you may be talking 7 figures, right? You may be talking in the millions of dollars already just for that 24 hours. And so, you know, if the software even could help, for example, have a 1% increase, even something that's quite modest, you know, you end up recovering a huge amount of production from that. And I think it's kind of an easy thing to think about. You say, oh yeah, increased by 1%. That doesn't maybe sound like so much, but it's important for us to highlight that even modest gains in production have a huge economic incentive. And then, you know, of course, these other components as well all play into that. And some of them are a little bit harder to quantify, but they're very important, right? If you were to have 1 less fugitive emissions event per year, right, there's certainly a big value to that. You know, optimizing your energy usage, you know, your energy bills coming down because of better equipment usage or eliminating variances in your system. And then also for your personnel, right? So, you know, your people have things that they need to do. They already have tasks to do, and if they're dealing with emergencies, then they can't always be dealing with their normal day-to-day maintenance as well as other important tasks that they're doing. And so the software isn't about replacing people, it's really about maximizing the people that you do have, giving them better tools and helping them better use their time. So you know, sort of with all of that as the background, I'll go ahead a couple of slides here, and you guys stop me if I'm going too fast, and feel free to ask any questions you have. But as far as equipment goes, you know, we're talking about sort of any kind of process, right? So you could have all types of different equipment. You might have valves, you might have different types of condensers or conditioners of some kind. You might have, heat exchangers or all kinds of different instrumentation, pumps, right? There's lots and lots of different types of equipment. Many of those different types of equipment have different types of failure modes, different ways that they could fail. And the reality is, I think that the second you start up your plant or your system, failure is already sort of occurring, right? Wear is occurring, corrosion is occurring, scaling is occurring right when you begin. And so I think we often have a conception like that something breaks and that's a single event and it happens in a single moment. But the reality is that failures in equipment are really much more progressive than that. And we've got a few example images here. We tried to pick a few things that maybe some people would have been familiar with, right? You might have wear inside of a valve, whether that's a ball valve losing its seal, or you possibly could have the same thing with a control valve plug or seat. Those are things that we're fairly familiar with from the valve side of things. Drive belts wear out, conveyors wear out, lines get scaled or they get plugged for different reasons. Leaks do occur, but generally, most of these failures are not just occurring in one instant. They're actually occurring over time. The wear is occurring over a period of weeks or months or even years. And so, deciding what the point is when something actually needs to be replaced can be quite difficult. I know that, maintenance managers have, all kinds of sort of preventive maintenance schedules that they might be using and saying, okay, well, we're going to replace these elements, after this lifespan so that we really avoid this failure that shuts us down. But you want to get the maximum life out of your equipment at the same time. So it's a bit of a two-edged sword. And really what this slide, just trying to express that idea, right? That failure does not happen in one moment. It really, in most cases, in the vast majority of cases, it happens over time. But there's a point where you do need to replace something, and you want to replace it then and before you end up with, a failure of the type that I'll call, catastrophic. And we know that when failures get to that point, when they break, what seems like that all of a sudden event and something starts to leak, or the process stops working overall and you've got to shut down, that your cost of repair is skyrocketing, right? Because you've introduced downtime. And downtime is very, very expensive to any facility. And then there's these other components we've talked about as well, right? There's emissions components to things. And there's also, the emergency component, how your people's time is being spent, as well as, the energy component of things and your efficiency. So there's a number of different portions to this, but, you can think of it that there's some point where things need to be replaced, and you don't always know exactly when that is. This is really what SamGuard is trying to help you understand. Okay, I've got lots of equipment, what needs to be fixed in the near future, and giving me enough warning about it that I can go and have a team do a bypass or whatever we need to do, or a limited shutdown to get something repaired and fixed so that I don't end up with a catastrophic failure or fugitive emissions, or some big emergency that's going to cost me a lot of money and a lot of headache, as well as the safety component of things. So, sort of a long story there, but short message that failures don't necessarily occur all at once. And then I'll go ahead and pass it over. I think I see that there's a question there. Sam, if you could read that, if it's something that we should answer now, I'm happy to do it, or we can go on.
Yeah, the question is, does it work for detecting shell and tube exchanger bundle leak?
Sorry, could you read it again?
It says, does it work for detecting shell and tube exchanger bundle leak?
Oh, yeah. Maya, did you have a comment?
Yeah. Yeah, first of all, we would have an event which is quite similar to this question, but unfortunately, I cannot tell which type of heat exchanger it was because we don't have this information from the customer. As long as you have any abnormal behavior which we can observe in the sensors, and the system would be able to detect it. What we need is that this information will be reflected in the data, in the sensors that we are monitoring.
Yeah, so as long as there are sensors surrounding this part of your system, right, there's data coming into the software, it definitely can detect that kind of failure. And Maya's going to talk about several use cases, and you'll be able to see how the data comes through and how the software identifies, okay, there might be an issue here. We'll give you a really good insight into that in the later part of the presentation. But I'll stop talking, and Lena, I'll let you go ahead here. I'll go on to the next slide.
Sure. So first of all, data is already here. Most of your equipment have embedded sensor, which continuously stream data to the DCS and then to data historian. When we are talking about 10, 20 sensors, there is no any need for AI, as a regular process engineer could support and analyze such kind of data. But when we are talking about thousands of sensors, hundreds of sensors, there is a need for the AI solution which will continuously monitor and looking for any abnormal behavior. Our solution will use your sensors. We are not providing any additional sensors. We just could recommend to the customer to buy more, but the approach is to use the existing sensors. We will connect directly from our solution to your historian database to take the data in real time. The data would be analyzed 24/7 by our patented algorithms, and the result would be presented in our web application for your team, as well as our digital transformation service. Could you go to, yeah. So what we need in order to install the SAMGuard solution? First of all, we're asking you to provide us a PNID. Why we need the PNID? We need the PNID in order to learn what are exactly the relationship between different kind of equipments and processes in your plant. Based on this knowledge, we build the causality graph. And the need for this causality graph is coming as part of understanding that the plant is a very noisy place. And every time there is an anomaly. But when the anomaly coming from the different corners, it's nothing saying about upcoming failure. But when the anomaly accumulates in one corner, this is exactly what we are looking for. Then the second step of such kind of analysis would be to find the root cause, which would be done again automatically by our patented algorithms. On top of digital twin, which would be built as part of our studio module of SAMGuard solution, we took the 1 year of historian data in order to learn the correlation between different sensors, to consider the different seasoning, as well as different operation modes. Both inputs will stream to our patented algorithms. The outcome of the patented algorithm would be the artificial model for each and every equipment in the plant. And as I mentioned previously, the model is not predefined. We are not bringing average model as part of our solution, which applicable to some customers. We build the model based on your PNID and based on your data. Additionally, we are taking the model, and the model will be recalculated continuously with any change that could happen in your plant, such as equipment replacement, maintenance period, and so on. As soon as the setup is finished, SAMGuard is online. From this point, every process real-time data would continuously stream to our solution. By identifying the dynamic limits provided by the error model, alerts would be presented. Those alerts would be communicated directly to our SAMGAR Pro specialist and then presented with clear recommendation to your operation and maintenance team. As part of the weekly meeting, or in case of urgency, it would be communicated in the same moment. Additionally, as part of our solution, every alert could be analyzed in terms of potential value saving. You can see here a different dashboard, different reports for different levels of roles in your organization. Next.
Yeah, sorry. I think we're gonna transition over to Maya, but I think there's a couple of questions and maybe Maya's the person to answer them. So we can answer those, Sam, before before going on to the case studies here. Did you want to help us out with those, Sam?
Yeah, sure. So the first one that came in is, in case these are not mentioned in the presentation, is there a learning period for this AI software to learn about my process?
Yes. After the building the normality cluster, which is actually artificial model for each and every equipment in your plant, we took 1 week of fine tuning, in which we will ask the customer about the how sensitive this equipment in terms of how critical this equipment of this customer. We will fine tuning, and then from this moment the result would be accurate.
Okay. And
Yeah,
follow
and
up to
Sam,
that.
let
Yeah,
me add to that. Sorry to interrupt you. You know, the learning period really is from this 1 year of historic data, right? So, you know, we're taking a year if your facility is not brand new, right? Which most aren't. If your facility is not brand new, if it's not a complete greenfield project, you're not starting from scratch, you know, you have all of this data you've already stored. And so after creating the digital twin model, we feed that 1 year of data into the software and say, okay, this is, you know, your baseline to help create these normality clusters, right? These baselines for each data tag. And part of the reason that it's a year of historical data is because it accounts for seasonality, right? Seasonal changes in the weather at your location. And you know, as far as the standard goes for this type of software, I've never seen anything that uses more data than that. You know, I've seen other things that are like, yeah, we use 100 hours or something like that. But you know, SamGuard really takes it to the next level by you know, considering that whole year of data, and so creating a really, what we'll call a really robust, from a data perspective, a very robust set of baselines for all of your different sensors or data nodes that you have. Sorry to cut in. Go ahead, Sam.
Oh, no, all good. Yeah, there's a couple more follow-up questions kind of around hardware. So how do you integrate the AI software to my current process control system, and then in brackets, Delta V or ABB?
So first of all, our general approach is not to touch directly the control system as the control system responsible for controlling the plant. And in most of the cases, we are working directly with the historian. There is a possibility to extract the CSV files and bring them to the SAMGARD if needed. We made such kind of integration previously. As I mentioned, for most of the cases, we have automatic connector, which will take the data directly. Our suggestion is not to use it directly from the DCS and to use a historian.
Okay.
Can I just ask if Lena's auditory changed there, or was it
Yeah,
just...
it sounded like your audio went a little quiet there, Lena.
We'll let Lena get that figured out, but I think Maya's next anyway. So
we should just answer the last question if we can, just because it's related as well.
Yeah, so it's just a follow-up. Is there any additional hardware required to implement your solution?
No.
Maya, why don't you take that?
There is no there is no hardware required by using the existing sensors. The only hardware that I could imagine to myself is a server, a physical server or cloud in some cases. And this is only in case if you prefer to install the solution on your premise.
Yeah, in case some of you didn't quite hear all of that, the reality is that there's two ways to use SamGuard. One is in the cloud and the other is on site. Many people prefer on site for security, obvious security reasons, right? Because they're data. And in that case, it needs to have its own dedicated server, which we can outline to you. It's not necessarily something that's really exotic as far as servers go. And if you use it in the cloud, that there's no hardware required at all. Hopefully, Maya and Lena, I said that right. But if we answer that question, I think we can pass it over here to Maya to talk about some of the cases and sort of what this actually looks like in action from a day-to-day basis.
Great. Thank you very much, Brant. Okay, so hello, everyone. Thank you for joining today's webinar. I'm excited to have the opportunity to walk you through several use cases and exemplify the value that you can reach out with our solution. Let's dive in and look inside of several use cases. The first one would be from a petrochemical plant. I hope you can see it already. Yeah, okay. Here we talk about actually a loop of a cascaded loop between a level of a receiver tank and a flow rate. As you can see in the green line, we're talking about the set point. You can see that the set point of the master of the level of the receiver is constant. But if you will take a closer look to the blue and pink trends, you would be able to see that the pink trend is talking about the stroke of the valve, and it is fluctuating and even reaches 100% opening. And together with it, we can see the flow, which is fluctuating. And this is something that is abnormal for the system, and therefore we received an alert about it. Taking this alert to the process engineer, provided a detection that probably we need to calibrate this valve. They calibrated it and then they managed to understand that actually the valve is not sealing well. Therefore, they took it out and checked it closely, and they found out that the plug which is supposed to maintain the flow is actually weared out. You can see the real picture that we received from the customer on the left side of the screen in the bottom. This is the plug that was found in this valve. And in comparison, you can see a new valve, a new plug, sorry. As you can see, it is totally weared out, which actually really made it difficult for the valve to maintain the flow. That was a very, very nice finding for the customers. It was important because he wanted to maintain this flow very carefully. And here we can see an example of how we managed to pinpoint a valve out of thousands. And in this specific petrochemical plant, it's even more than 1,000 tags. It's more like 10,000 tags. We could pinpoint specific valve in which the maintenance team need to take a look. And the detection is here in front of you. Please, Brent. Thank you. Next use case is talking about a mining industry. Here we are talking about a pump which is actually located on a barge in the middle of the sea, which means that every maintenance activity is actually quite complicated maintenance activity because it requires the maintenance team to go into the sea. What we saw in this detection was in the first glance, it was actually the combination between the temperature of the motor, this is the purple trend, which is rising, and slight fluctuations in the sealant flow, which you can see in the brown trend. Taking this observation to the process engineer, provided the feedback from the process engineer, oh, it's okay, it's ambient temperature, it is very hot right now, probably this is the cause of this alert. The process engineer from our side insisted as he received additional indications about the pressure, which is the green trend, which is actually decreasing in parallel to the temperature increasing and the flow fluctuation. Providing this combination of parameters enabled the process engineer to understand that there is a real problem and that she should send the maintenance team to the barge. Going to the barge provided the detection of a leakage in the ceiling water, and that was a very, very important detection. As I mentioned, there is no personnel sitting on the barge. They are detecting the process from very distant from the shore, and therefore it was very important identification that allowed them to prevent a failure, which would have been occurred in a few hours or days or weeks later on. Next use case is talking about another petrochemical customer. Here we are talking about a very, very sensitive and important system, which is the flare system. We're talking about a control valve, a pressure control valve inside of this system, which is responsible for the T-pilot gas. And what we can see here is that we have the flow itself, the pressure which is maintained, we have in the blue bright line. The yellow line is the set point. And then we have the opening position, the stroke of the valve in purple. We can see that without any change, suddenly the valve is opening to 30% instead of 20%. And this is something that is abnormal and means that something occurred here, and we need to understand what happened. And as I mentioned, it is a very, very, very sensitive system, as a flare means environmental consequences. For this valve, it was found that there was a malfunctioning device which actually provided a faulty value, which caused the control valve to open to a more percentage than needed. Now, in case of a real situation, in case they didn't know that this is a faulty device right now, they would have eventually get to a real situation of a flare. The estimation from the customer for this kind of detection was between $10,000 to $100,000 of savings. And here, as Brent mentioned before, we're not talking only about money, not only about production or emergency or maximize the personnel. We're talking about a mission. And I think we're all understanding very, very well what are the consequences of every environmental action that happens. So that was another example for a detection that SAMGuard is able to provide. And last but not least, because there are a lot of other different events from different other processes, here we are talking about a chemical plant. There was a question before about a heat exchanger, so this is the use case. What we can see in the brown trend is the flow rate of caustic soda, which is an hazardous material and very corrosive. And also we can see the temperature control valve. We can see in the purple the position, in green the value itself, and in red the set point. What we can see here is that the set point was not changed, but suddenly there is a decrease in the flow together with a decrease in the temperature. This early finding, assisted the maintenance team and the process team to go and look hands-on to the field and look and check what happened to the heat exchanger. And it was found that there was a leakage in the caustic soda. For the team, it was very, very essential detection because, first of all, it was in a very early stage. And additionally, they really suffer from these kind of leakages because they use caustic soda. And therefore, they estimated the value out of this detection in $10,000 to $50,000 savings. Thank you. If there are no questions, I would hand on to Brant.
Thank you, Maya. That was perfect. We talked about 4 use cases there. Our friends at SAMGuard have like dozens of case studies, right? So we just picked a few, trying to show sort of a representative example. Your process, your facility may be doing something different, right? Your system may be doing something quite different than any of these. But that's, I think, one of the beauties of the SAMGuard software is that it's not a respecter of what the process is. as long as there's data that's coming in, it can and will analyze it continuously, 24 hours a day, no breaks, no vacations. And something else that, when I first started to look at these case studies and see that data, I sort of started to do this thing, this sort of armchair quarterback, where I'd look and say, oh yeah, I can sort of see where there's a problem occurring, right? Like I can see where it's starting to get out of whack. But the reality is that, you probably don't have the luxury of 100 process engineers sitting around constantly monitoring every pair of data that exists, right, in any related data nodes. And that's one huge burden that the software takes off of your personnel, is that they don't have to feel this need necessarily to monitor individual things all the time. I know that DCS systems have some ability to do some monitoring, but generally, as far as I understand, there's a high limit and there's a low limit. They're static, and as long as things are staying within those limits, you won't get an alert. Another issue is that DCS systems often give you too many alerts. So you end up with this alert fatigue syndrome, or this cry wolf syndrome, where nobody really seems to believe them anymore because the plant's still working and you're getting all these alerts. So a couple of things to kind of notice. And then I'll say one more thing here, and maybe Maya, you have another comment before we do a couple questions and I wrap up. When you look at these examples, and I'll go back to case study 2 here, if you look at the alert line and you say, okay, well, to the left of that line, am I indicating just by looking at it any issue? I think for all of us, the answer is no, right? Like you look at that data and you say, I don't really see anything occurring. Spikes like these sometimes are things that, and I don't know if you can see my cursor, but some of those spikes maybe, trigger something in the DCS, but that's a thing where somebody goes and looks and says, actually, the data looks just fine. And SamGuard is using these really quite intense statistical algorithms to see that there, is enough change in the averages and when that occurs, and it detects it at a very early stage. And you can see the timeline here actually gives you time to do something about it, right? And we talked about how failures occur over time. So, SamGuard is giving you, and not just necessarily like minutes before something is failing, but hours or days, or even in some cases weeks, right, to make a plan and address an issue, or do a root cause analysis and to diagnose what is happening in a certain part of your plant. And so there's real value there, and I think there's some nuance to it, which is why we give the little bit extra explanation. Sam, if there's a couple of questions, I think I'm fine to do them now because I just have a couple of slides left at the end here.
Brand, can I just jump in for a
Go ahead,
second?
Maya. Yeah.
Yeah, thanks. Only to add on top of what Brent said is that in addition to the situation that Brent mentioned with a lot of events coming up and the operator presses the acknowledge, there is also a situation where we think that we are protected because there is supposed to be a limit with a minimum and maximum, but actually somebody changed it without understanding the consequences. And this is something that we managed to find several times, a very, very good detections where the customer actually thought that it, for sure, he has the alert about it, but when going to the alert management screen, they saw that somebody changed it and nobody knew that it was changed, and they would not get the alert on time. So this is another scenario. And another scenario that I can think about and also happens is that failures are usually happens from various reasons, and you can never cover, no matter how amazing process engineer and how experienced you are and how the technical manual is very, very clear and detailed. There are failures that actually surprises you, and for that failures you will not have predefined limits. And with SamGuard, you get another layer of protection. It is not instead of the DCS, it's an addition to it. And this is another layer of protection which is not limited by predefined limits. Thank you.
Great. Yeah, so there was one question, you briefly touched on it already on the heat exchanger, but I'm just going to reiterate it. So for a specific case, for example, heat exchanger, do you require some historic data from the client, aka engineering department, or feedback with, let's say, a table to complete the data set?
What we are using is the historian of 1 year of historian. In this historian, as long as we have the parameters which are changing and behave in an abnormal situation, we will be able to detect the anomaly.
Okay, perfect. And that segues into another question. Is there a limit on the number of historian tags that AI software can monitor and alert?
There is no limitation. All sensors that are presented in your historian database would be exported to our solution and analyzed.
Okay. And then a follow-up from Juan was, could you please extend an explanation on training data?
The training data, as Maya already mentioned, it's 1 year of historian data in frequency of 1 minute in most of the cases for any kind of parameters that presented within the equipment.
Perfect.
Lena, can I get you just to explain a little bit? So when this starts, if I recall from our training, we take the historian data and
Correct.
we build the causality graph, but we sit with the client, we sit with the process engineers, and we get their input into the criticality of each particular part of their process. So once we produce the digital twin, we sit with them and we have discussions. That process typically takes 1 to 2 weeks. And at the end of that period, we are basically a go live. So that is the critical integration stage where we take the data, we build a model, and then we use the client's input to ensure we tailor it and tweak it to their plant. Is that correct?
Yeah, fully correct. And yeah, this exactly the stages. We taken the historian data. We build the digital twin as part of a studio model presented in our solution. Based on those relationship correlations that you have in historian data, we building the model. And this is our base. This model would be continuously recalculated with any new upcoming data coming to the system, with any change in your plan, such as maintenance period or equipment replacement, and so on.
Okay. And one more real quick one. Does the AI software monitor all the historian tags, or can the tags be monitored for PM be configured?
We are able to connect it depending on the process. Usually, from our experience, there are very few plants who uses 100% of their sensors. Usually, the flags are less relevant because it is, you immediately know about something that is flagged. But all this developing, upcoming failures, they are usually from continuous tags, from pressure, from level, from flow and temperature, and etc. And all those tags, we will tailor them up into the model and they will be monitored.
Perfect. And we do have about 5 more questions, but why don't we finish the remaining 2 slides and then we'll get to the rest of them at the end.
Yeah, all
No
good.
problem. Okay.
I'm going to be quick here so we can get to a couple more questions. And I see that there are others that are coming in as well. I'll let Sam kind of curate those. So as far as the economic case for something like this, right? This is an example from an actual plant, and we've tried to highlight sort of the high line items here, but I think the reality is they were at something like 96.5% availability, which is the axis on the left there. And they implemented the software, somewhat after April 2019. And over the course of the year, they ended up getting, about 1.5% better plant availability, right? And I don't think that was a coincidence. And all plants will have some sort of ups and downs, right? There's some variability, and you can kind of see that in the data that's coming through as far as their availability from any given day or any given week, however they're measuring this. But I think you can see the correlation there, and to be able to reach their availability goal and to increase their equipment reliability and then reduce their costs of repair, right? So there is probably the biggest economic incentive is to increase your plant availability, right? Because then you're getting more production that you wouldn't have got otherwise. But there's also the maintenance component of it, right? If you're replacing equipment before everything goes bang and things get really, really bad, then you're probably saving some money on the equipment itself. But more than that, right, it's about the labor. The money that you're saving in the time that the people are spending, whether that's people that you have on site full time or whether you have contracted people, either way, right? So that's another case about the return on investment. We can provide more case studies and more numbers of this type for anyone that's interested. And then if there's any questions about how licensing works, so Nova is a licensed distributor of this software. And the way we have it set up now, the monitoring support from the team at SamGuard is mandatory during the first year at least. So this is how we really get you off the ground and help your maintenance team and your process engineers understand what the software is doing and what it's telling them, so that they don't have to feel like, oh great, somebody in the management decided that we needed to use this software, but all that means for me is more work and that I've got to. We don't want that situation, right, where it's just a software that sits on the shelf. And so there's a periodic meeting that occurs at least sort of weekly, right, with the SamGuard process specialist who's going to be saying, okay, well, let's look at these alerts together and see what's going on. You can send your team to investigate ones, or maybe there's ones that you can say right away, no, we were having a scheduled shutdown in that part of the plant. So that's obviously not an issue. As far as pricing goes, it does depend on the number of data tags, right? So there's a tiered pricing schedule based on, how many data tags, which roughly correlates, right, to the size of your plant, your facility, or your system. We're of course open to doing, sort of trial type of things where it's a more sort of narrow part of your plant that's really having issues. And we can answer other questions like that offline. That was the end of the presentation part of this. Please feel free to reach out to me directly. Of course, Sam can get you connected up with me as well, and we can get all the expertise you need and get meetings scheduled or anything else, any other questions answered from Elena and Maya. And we do appreciate them, especially being with us after work hours. So Sam, that's it for me. I'll be quiet and we can do any other questions that we've got.
Sounds good. So couple real quick ones. Is it possible to integrate with SAP?
Yes, I will combine it also with another question that I saw about Pi. So yes, the answer about SAP. Regarding Pi, first of all, it is one of our main resources in most of the plans for the historian, but we're not only able to connect directly to Pi, we're also able to take the process diagrams and to integrate it into our system. And in that way, when you see trend, you can switch to the Pi vision that you are used to see, and the tags are being lighted at the same color that the tags are presented. And in that way, it is very, very convenient to add tags by only clicking on the correct place. So the answer for both is yes.
Perfect. There's two that are fairly related. Does the system keep learning from the data, or the learning happens only during the training?
The system keep learning within the data, and not only in a training period, and system learning not just from the new occurrences such as maintenance periods that I mentioned previously, or replacement of the equipment, but also system learning from the user feedback. That's why we encapsulate in our solution not only the artificial intelligence, but also the human intelligence. Every click within the software will provide input to algorithms.
Perfect. And kind of a follow-up, does the analysis happen in real time throughout the day, or is the data exported at the end of each day or the end of each period for analysis?
The analysis happens in real time period of time. That means that every 5-10 minutes, we will reach out to the historian database, take the data, and throw and data would be analyzed by our algorithms.
Right on. And let me see if I can word this properly. being that the data acquirement from the customer is a key stage, how is it faced with the customer at the beginning of the project for a control valve, for example? Not sure I entirely understand that.
Yeah. Is it possible to rephrase it, please?
I tried to do it live, but failed. Juan, if you could perhaps retype that question in another way, we can get to it, or we can follow up with you directly after this call.
I think I might understand. I think one might be asking about, so for key equipment or something like that, right? You're saying, if we know we're going to be installing something that's a really important piece of equipment, is there, I guess, guidance that we can give as far as what data would be valuable to get out of that piece of equipment that could be fed into SamGuard? I think that's maybe what he's asking.
Okay, so in general, we have recommendations about most of the types of the equipments, and the most common of them. But usually, as we know the reality of plant, it costs money to add the measurements. So first of all, we take all the data that is available, and we try to see, and if there is something that is really, really missing, we can recommend to add it.
Yeah, and from the Nova side, the valves, and Juan has asked about the control valve, for example, specifically. That's definitely something that Nova can comment on right at the beginning and say, this is the data that you're probably getting out of your valve from the positioner, for example, and we would recommend X, Y, or Z sensor or piece of measurement equipment in addition to that for that specific valve. That's definitely something that we would comment on, and we can help with from the Nova side. So as far as the team answering all the questions, part of it from the SamGuard side and part of it from the Nova side.
Okay, another follow-up question. Is it possible to add data tags to the existing license later in case of any future expansion in the plant?
Yes, sure.
Yeah, no problem at all.
Right on. Well, I think we're a little bit over time, so why don't we wrap it up there? Thanks again for everyone for joining the call. And Brand, if you have any final words.
Really appreciate everybody. Really appreciate Lena and Maya joining us after hours. Appreciate their expertise on the software. And please do reach out to us with any other questions, even if they're generic. That's completely fine. Glad to engage in a conversation, have a meeting. There's also a live demo that we can do of the software. There's definitely a lot more as far as the technical aspect of how the software works that we're willing to go into, and any amount of depth that you're interested to hear. So thank you so much, everyone, for joining us. Really appreciate it.
Thank you very much.
Thank
Thanks,
you very
folks.
much.
Thanks.
Have a good day.